All right. Hey everyone, I'm David Room. We're going to do some live coding tonight on the project, and I'll get into that in just a little bit. Before we get started, I'm just going to share a link on Twitter now that we're live. And I'm going to double check the audio because I had some issues with that last time. So you're going to hear an echo here for just a little bit while I check the audio. And then we'll move on. Now that we're live. Okay. So that appears to be working. Let me skip this ahead and share the link again. I've had a busy last couple of weeks on the project, but unfortunately not too much that is too interesting to show. I went down an interesting rabbit hole. Uh, uh, Interesting rabbit hole, which was correct color space conversions for video encoding. So I added a nice, a better, like an improved video capture, or like video capture capability to the game that pipes images into FFmpeg. And I was reminded of the fact that the colors are all washed out and weird, and um, and that really started to bother me. So I spent a couple days figuring out what was going on with that, and figuring that out as best as I could. And now I am ready to move on back to some, like, actually creating content or assets for the game. I don't like the word content. We'll say assets. And I thought it would be fun to share. So we're gonna just do some late night live coding. I'm probably not gonna listen to a ton. I'm not gonna listen to music tonight because I don't want to wear headphones. Just want to hang out. Might not talk a lot. I'll try to explain in general what I'm doing here, but I'm just gonna make some headway on this specific thing and use creating a video as a reason to keep myself focused and yeah, focused on what I'm doing and being productive. So I'll show you the current state. So let me just actually bring up my tracking spreadsheet. So beginning of the year, I created this tracking spreadsheet that has the different assets that I need for the game, and I'm starting to fill stuff in. So these are all ships, and I believe at least started all of the ships. Looking back through a sketchbook, there's a couple ship ideas that I had that I have not started and are not in here, so I need to add those. I'm not exactly sure where they would be used in missions, so that would be something to figure out. What is missing here is a second turret, and then I had three space stations. The first one, Shima Station, is kind of the protagonist's home base. I sketched that out and made some progress towards a higher detail version of it last year. So that's at least started. The second space station is something that is going to be kind of in the background in a couple of missions, or maybe a couple of different variations on it, since it's sort of a modular design. So that needed to be built, so that's what I'm working on now. There will be a third maybe third and fourth space stations too. Maybe this third one might not actually end up being necessary. So we're working on this second space station now, and basically we have the low poly base model a little bit started on different details, but there are some bigger details that are needed that we're going to work on tonight. So let me fire up the game, and I think we're in a spot here where we're going to launch into flying around the space station. So I also I guess one thing I have been working on that you can see is I've tweaked the HUD a bit, made the font sizes a little bit smaller, moved things around. I moved the radar up from behind the ship to up here when we're in the external mode. And yeah, so this is the space station, and it's kind of like a tower-like structure with these two rings that aren't for artificial gravity, but are mainly just designed to be a space where a lot of ships could dock around it. And the large size of the radius of the rings is just so that in each of these segments, potentially a ship that's quite large could dock. You can see there's a docking ring. Oh, and I'm going to clip right through it because that's another thing this is missing is collisions. But yeah, there's a facet here that's quite large that potentially a large ship could kind of dock against. So like if we look at this external view, you can see my fighter, which is kind of a large fighter. Like it's this particular fighter is like quite a bit bigger than a normal like modern fighter plane. It's like between the size of a fighter plane and something like a Blackbird. And you can see the docking ring kind of for scale, like a standing person could fit through that docking ring. So there's enough space in each of these segments that potentially a really large ship could be like sort of parked there in that spot. So, oop, that's funny. I just had a little crash there. That's fine. Yeah. So what's missing here? What's missing in the space station? So in general, the main design of it, or like what I like to call a sort of sketch of it, is done. We have this tower structure. We have the segments. We have the sort of engineering section at the bottom of it where we have fuel tanks and radiators, and then on the top and bottom too we have antennas. And something that I need to do here on these antennas that I may or may not work on tonight is reducing the detail of these, because I'm trying to sort of keep a smaller number of polygons when possible, and there are a lot of extra polygons here just for these antennas, which really don't need to have that many. You're not going to be flying too close to this antenna. If you are flying close enough to see it, you're probably going to crash into it. So that can be a lot fewer polygons. And then we can use that polygon data to better add some larger detail that's more visible from far away on different parts of the station. There, I clipped through it again. That's fine. So what we're going to add though is the station needs a system of thrusters that can be used to realign it, kind of keep it in its place and orientation in orbit. And those are going to be a set of arms that have end drives or thrust rings, which are my sort of magic drives that I have in my universe. They're not they're they don't use man, I'm sorry guys, I'm having trouble thinking here. They don't use reactive mass. They work kind of like propellers in ether that underlies space. So what we're gonna have is probably close to the top or at the top of the station here. There's going to be kind of like 4 arms sticking out that have a cluster of thrusters on each end at the top and then at the bottom. And maybe we could think about having one in the middle as well. I'm not sure if that would really serve much of a purpose, but you know, you could see having a backup system. And then the sort of function of this thing is, aside from just having like a function in the actual space station, it's going to provide some interesting detail, especially when you get up more close to the station to look at. So I am not an expert designer or anything, but something that I'm learning is really important for good designs is to have a mixture of sort of low, medium, and high detail. So in this space station, you can kind of see the low or larger details is the big tower and ring structure, and then maybe some very high detail is like when you get very close. And eventually, this would be a level of detail thing where these models wouldn't pop in until you got close enough to actually see them. You have these docking rings, which have a lot of very small detail in them compared to the size of the station. Well, the antennas and this sort of thruster alignment system that I'm imagining would be sort of like a good medium level of detail, where there's details that are sort of in between, in size between those things. And I think that's going to really tie the design together and make it look nice. So let's get to it. And just before I start, I've been really getting into trying to sketch out designs on paper before I model them. It really, really helps. I used to just try to dive right into the programming, but having designs is really helpful. So here's just a little sketch that I made on my church bulletin. And so here, this is like the end of one of these arms. So you can see there's 4 sticking out. We have a little cluster of these M thrusters. And then this is a little piece that has some radiators sticking out. These aren't going to glow. They'll be dark, but I think the idea is those radiators are either for waste heat from the thrusters. They're going to be quite large, so they would maybe generate a lot more heat than a spacecraft thrusters, so they need their own radiators. Or you might think of them as radiators for a backup reactor system. So depending on how things look, I might try to bake that into the things. And I guess another piece of detail I had here, an idea for here too, is kind of like a circular heat shield between the main radiators on the space station and the fuel tank. So I might try to add that as well too. So we'll see how far we get, how all this looks. I think we'll try to get this this thruster system going and kind of see how it looks on the design and go from there. Okay. So let's see where we are. So I usually use this bench bench script as a way to just run the piece of whatever I'm currently working on. So you can see right now I have it running the code that generates the space station, and then after it runs, I scale down the parts and open them in Blender so we can view it in Blender too. I'll probably disable the Blender viewer here in just a second because we're going to be able to probably see everything we need to in the other viewer, unless we run into problems. So okay. Okay, yeah, there's some things I need to disable here. These are the windows. I was debugging that. Here's the whole station. And here's what it looks like in Blender. And for people who are familiar with Blender and different like approaches to procedural or programmatic modeling with Blender, one thing that's pretty unique about my workflow versus a lot of tutorials that you see is I'm not generating this in Blender. I'm not using geometry nodes, and I'm not running the Python code that generates these meshes in Blender, or even really using Blender's functionality to do it. I'm generating it all in Python code using other libraries, and then I have code that lets me basically control Blender from Python. So I kind of build something and then launch Blender with some code that reads it in. So it's a little bit different workflow than other stuff. It's kind of like Python first, Blender as one potential viewer or one potential way to interact with this. And in this particular case, the final destination for this model is not Blender, but it's the game, and that's a different engine, you know, a totally different kind of set of file formats and things like that. But we can look at this in Blender, and this is at a 0.2 scale to what it is in the game, and it also doesn't really have materials on it. There's no light, so we don't get anything if we like turn rendering on. So this is kind of just for interactively viewing the model hierarchy and stuff like that. And I'm just probably locked at Blender turning on rendering for no reason. But we can go back here and close Blender that way, and it's fine. I know it didn't crash. Okay, so let's just quick. I'm going to run this again and disable those other these views, because we're not working on Windows anymore, so we can turn these off. And this should, yeah, the whole thing should run pretty quick. Yeah, boom. I had a different method for generating the windows before that is like more capable, but in this case wasn't really needed, and that was slow. With that rewritten, you can see it takes just a couple seconds, if more than a second at all, to generate this model. And it's not a single model, it's a hierarchy of models. You can see all of the detail in it in the wireframe here. Okay, so let's work on these thruster pieces here. I'm gonna scoot in. I've been trying to practice using the keyboard more. In my work, so I'm gonna take this as an opportunity to practice that a little bit. Just doing a little bit of cleanup here. As long as I'm seeing it. Oops. Okay. Call it thrust array. I haven't really coded up any level of detail stuff here yet, but we'll keep it in. That's one big part that's missing from my game that I need to figure out, and I'm hoping to at least start trying to implement in the next couple of weeks, is a system for doing level of detail that actually uses the level of detail functionality in Panda 3D. Panda 3D is the engine that I'm using, so it can swap out different models depending on how far away you are. It's a little tricky to do that the way I've set things up, so I need to kind of figure out a good way to make level of detail work nice with my approach. And I think we're probably going to have 4 of these, but we could have 2. So what I'm going to start to do now is set up some constants that describe the dimensions of these things. So let's just see. So the radius of the rings is 400 meters. So I'm thinking something like 125 meters for the length of the beam that this thruster block is on. And let's see here. The actual block itself should be pretty big. Maybe like 6 meters. So then the radius is going to, of an individual ring on there, is going to be like 3 or 4. And the radius of this beam should be somewhat less than this. So also maybe, oh wait, no, this is too big. Actually, I think this isn't big enough. I think we're gonna double this. And the radius of this is gonna be somewhat less, so that's gonna be 5. Actually, we'll just call this side so we know it's not a radius. String radius, and then I know I want an inset on these things for some detail, so ring inset will be 0.5, and then for this the section that has the fins on it for the radiators is going to be a little bit wider than this beam, so yeah, and a little bit wider than the side of the block, so the radiator, like, we'll call it sleeve, we'll call it the sleeve. Radius will be something like 6. Actually, it's still like 6.5. And then the rad low, we'll do a length of that sleeve. Not a lot to look at right now, but I find it best to sketch these variables out first. Then you can go pretty quick when you're doing the actual modeling. Something in programming that I find is that one of the biggest challenges is naming things. So sometimes if you can get that, like what I'm doing right now, you can get that out of the way first. It makes things a little bit easier. Wait. Width should be a lot smaller, like 5. Length should be 18, and thickness is 2. Okay, so I think we've got all of the main parts that I'm thinking about, with the exception of like the number of sides of things, and those I'm cool with kind of hard coding as I go, so I'm not going to worry about that. Okay, so let's get started here. So make the beam. And that's 6-sided. Zoom out a little bit here. Okay. And then we'll do the beam, the block, and the sleeve. We'll put those together, and then we'll take a look at it. So the block is going to just be a box mesh of side. We can add a little bit of interest to this a bit later by having different dimensions for each side, but for now we'll do that. The sleeve is going to be another cylinder. And then the number of subdivisions here is going to be, I want to be bigger, so something like maybe 12. Okay, so now let's concatenate this stuff together. just gonna do this so we can reuse this when we're aligning the different pieces. And if we want to come back later and separate this into separate parts, like we might want to do that for like a high detail version of the station, we can, these are actually all y coordinates, so we can just do that. That's actually easier than doing an offset. Thrust, sleeve length divided by 2. Okay, and we're just gonna, for now, we're just gonna view this beam, and we're going to exit. And just for now, so we're not wasting any time back here in our bench, we can just call this thrust array function directly. So station b dot thrust array and log 0. So let's take a look what we have. Oh, by. Simple mistake. Okay, now we've got an inhomogeneous part. Oh, I've already got these here. Don't need those. Okay. Oh, I need to subtract. Oh, this needs to be divided by 2. Okay, yeah, so you can see now how this is looking something like this piece right here. And I think what I'll do is I'll make all of the rings together another separate piece so we can make those a different color, but we don't end up kind of cluttering this up with too many different parts. And then we can adjust the sizes and level of detail and stuff once we can see everything in context. All right, so yeah, let's do the rings, and then we can add the... Oh, and I think I was picturing a little, might be picturing a little heat shield there too. I started thinking about this, like if you have radiators, even if the majority of the heat is coming off one side, if you have other components kind of off the end, they should be shielded somehow. And I find it very helpful to think about the functions of things because it almost always yields more interesting designs. I'm not really interested in making designs where I'm just adding random detail. I'd rather have things sort of look simpler, and the detail come from things that, you know, appear to have a purpose. Fictional world, nothing's perfect, but you know, it's good to have things look functional, in my opinion. Or that's my that's my philosophy as far as design goes. So what are we going to do here? A single ring, we're not actually going to use a cylinder because we want to use that inset. We'll do a single ring, and then we'll rotate and align 5 of them and concatenate them together. So our single ring, and actually let's we need a ring like a height. So like how much should it stick out of the block? I would say it should stick out if the radius is 4 meters, it should stick out maybe like 1.5 or 2.5. Let's try 2.5. So we're going to make a solid from ribs. Solid from ribs, triangulate. So these are all, if you're watching this for the first time, these are all sort of custom modeling functions that I built that construct triangle meshes from different primitives using pretty straightforward operations. So in this case, we're going to make a ring of vertices for the bottom, a ring of vertices for the top that's inset a little bit, and then build a sort of like a tapered cylinder by connecting them together and adding in faces. So, and I call those rings of vertices ribs. So, rib is going to be a circle of radius, thrust ring, rad, and we'll do we'll do 8. Just click both of them because we want to set, and we'll construct typically for thrusters. So like the main components of the ship, the y-axis is forward and backwards. For things that I'm sticking onto surfaces, I have Z up. So we'll construct this thruster with Z up. So we'll attach Z to rib A at thrust ring height, and then we'll attach Z to rib A minus thrust ring height, and that will allow it to intersect through. So this radius will actually be the radius of the part that's like inside. So it's actually going to be halfway between the inset and not. So actually, I think I want to increase this inset. It will be 3 on the outside, 3.5 where it intersects the surface, and 4 on the inside. So there's the ring, and then for the rings, we're going to concat together some different versions of it. So first we want to translate this thing out to be offset to the surface of the block. And this is where we'll have to tweak this if we're going to have the block have different dimensions on different sides, but for now we won't have to worry about it. But we're going to translate it in Z at thrust block side divided by 2, and then we'll concatenate. So we're gonna have one that's just as is. That's Z. Rotate, and these are all going to be constants. So we're going to have one that we rotate rotation Y 180. So this will be the top and bottom, and then we'll have the sides. So these are going to be rotations Y 90 and negative 90, and then one in the front, which will be X 90. Oops. All right, let's see if I'm thinking about this right. Rings, and then let's toss. We want to translate rings at the same place as the block. So we'll see if this works. Oh, and I did say I wanted that to be a separate part. So yeah, we'll handle that separately. Okay, yep, that looks pretty good. I just need to flip the faces, and it's not there, of course. So yeah, I think I kind of have, I always forget which way I have it, but I have it set up so that when you're constructing these solids from ribs, you want to do it negative to positive. So like the rear of something first, and then the outside. Yeah. All right, so now we want to set this up with separate parts. And now that I'm thinking about this, I think I want to have 3 separate parts here. I want to have the beam, I want to have the block and the sleeve, and I want to have the thrusters. So instead of a mesh here, we're gonna set up parts. So we'll have our result part set. We'll have our root will be empty parts. So parts is the way I describe scene, kind of generic scene hierarchies in my code. And these can be exported to Blender. They can be exported to the engine. They can be just flattened down into a single mesh. It's kind of fun writing stuff like this yourself because it has just the functionality that you want. No more, no less. And actually, let's just right away, let's make the beam the root because there's I don't know if there's really a good reason to have an extra thing in there. So we'll have the beam be the root. We'll call the combination of the block and the sleeve the assembly, and yeah, we'll make the coordinate system of that be right in between the two of them, regardless of what the sizes are. Something else with this is you can't spend too much time stressing out about like getting the coordinate systems of things exactly right. You want them to be somewhat meaningful for like if you have things blow up and you want the parts to be rotating about the origins and stuff like that, but I feel like you can always recalculate that later. It's best when you're doing this kind of interactive programming to just choose origins that are easy to work with. So we're going to translate mesh. The block, we'll translate that forward by half the block side, and we'll translate the sleeve backward by half the sleeve length. Sleeve length divided by 2, so that's the assembly, and that will be basically at assembly y is going to be the beam length divided by 2 minus the block side length. So equals assembly, and the transformation is going to be a translation only in the assembly y. And then the rings is going to be, oh, and this thing's parent is going to be beam aim. And the rings, the parent will be the assembly, and the transformation is going to be a translation where we are shifting forward half of the thruster side. All right, should we see how we did now? So instead of this, we're going to view parts. I'm sure we did something wrong here. Almost. Oh, and I just, oh, I just didn't put a model for the rings. There we go. Okay, yeah. Almost. Okay, so it looks like the only thing that we have is that we just have the sleeve and the block flipped around here. And maybe the, yeah, so we want, oh, I see what's going on. This needs to be backwards like this. Okay, and also this needs to be x negative 90 because we want it to be on this forward side. Yep, okay, so that looks good. Oh, and it looks like yeah, rib B here. Okay, and I need to swap rib A and rib B around. Get rid of this to do. I think we're close to done here. Okay, yeah. All right, so that's good. The height is a little bit high, and these also could be a little bit bigger. So here's kind of my reference, but we can tweak. So the ring height can be more like 1.5. Let's see if that solves the problem. Yeah. That does it pretty well. And I want to make the sleeve a little bit bigger. So we'll bump it up quite a bit. There's kind of a science to how you size different parts so that they look interesting next to each other. There's some mathematical rules kind of dealing with relative sizes that I should probably be employing here. but we can kind of eyeball it. Yeah. And I don't think I want to add a heat disk here. I think it's going to be enough detail as is. Okay, so now we just need to add the little radiators to the sleeve. So yeah, sweet. And does this spin in Y? Yeah, okay, cool. I sometimes forget which parts I have. So sleeve rads low equals mu dot spin rad low for 0, and then we just need to come up with rad low, which is going to be a box mesh in with these things. So our x coordinate is going to be the width out, y coordinate is going to be the length, and the z coordinate is going to be the thickness. And then we got to translate this thing out. So we want to translate it out. Translate mesh x. So if we translate it out to the sleeve to here, then it's going to be half buried in there. So we'll just do a overlap here. Jeez, I can't type. It's almost like it's midnight and I really should go to bed, but this is my time to work. Okay, so overlap, we'll say overlap of 0.1. 0.1. Okay. Wrong one. Okay. There we go. Oh, okay. There we go. Yeah, I need a refresher on some of these controls. Okay. So yeah, so we want to do it this much plus half of the width. So, and I'm just gonna start a new line here because this is long. Rad width by 2, and then minus the overlap. And then we can spin it, and then we can concat it. So sleeve is mu dot cat sleeve, and it's low. And then in a higher detail application, we could union these things instead of concatenating them together. But we're just gonna stick with concatenation because it's gonna actually save some vertices, and it's a little bit more maybe authentic to the style that I'm going for, which is like the sort of mid-90s low poly style. More things were modeled as separate meshes rather than like a skinned model, so I don't feel too bad about doing things this way. Yeah, so let's see how this looks now. Oh, once again I've goofed up my inhomogeneous. Oh, I think this guy returns a list of meshes that I need to, yeah, I need to concat this. Perfect. So you can see now there's that 0.1 meter. That's actually not enough because it ends up right on the edge. Is that actually 0.1 meter? Or did I do something else wrong here? So here it should be like right on the edge. Oh yeah, I guess it is. That was just 0.1 meters because these things are pretty big. They're like a radius of 4, so it's like they're like 8 meters across. Pretty big. I think we might end up reducing the size of this guy a bit. I guess we'll see. Yeah, so we want that overlap to be bigger. And we'll do a 1/4 meter. And okay, yeah, and these are also too thick. They should not be that thick. Yeah, they should be like that thick. Cool. And then do we have the other details that we want? We've got a little gap here. We've got a little gap here. I think I'm going to splurge on some extra vertices and make this block here have some little bevels in it. So we're gonna do instead of this, we're gonna do a rib that is a rect 2D of and I think, yeah, just gotta repeat this and we'll parameterize that too. Something like 2 meters. Boom. Yeah, that's it. Okay, so now u dot bevel polygon chord rib rust block bev. Okay, now we can do the same thing that we did here below where we build the block with the little offsets. So solid from ribs, triangulate. We could add a chamfer in here too if we want. I don't want to right now. And this just takes ribs, so we can get rid of this. We'll build it in Y, rib minus block side divided by 2. And like this. All right, let's take a look at that. Whoops. Oh, block. Why is that inverted? Oh, rect 2D is probably backwards. Let's see. Let me just look and see. I believe they're supposed to be counterclockwise. Width half minus height half. That looks counterclockwise. Let's just take a look. I just want to make sure I don't have some kind of flipping going on somewhere that I'm not expecting. This isn't flipping it, is it? 1, 2, 3, 4. That's weird. What gives? Maybe it's because I'm constructing it in Y instead of Z. Oh, that's funny. Okay. It's funny how that stuff works. Yeah, okay, so when we're going in Y, we have to go positive and negative. When we're going in Z, we have to go the other direction. That's funny. Okay. Okay, so what we have to do now is we just have to put these together into a set of 4 and then attach that into the station. So we're going to have a center here, kind of like the other parts. So we're going to have a center that has a radius. And we want something like this. So let's see here. This is really goofy. Is there a reason? I need to basically write, if I don't already have it, I need to write this function with the with this chamfer transferring thing built in. Oh, nice. Doug Wise is here. He says, likely hopping in too late to fully catch up, but looked like some cool station views early on. Yeah, so, Doug, I'm just working on this this space station like thruster array, and I am just getting to the point where we're going to put it all together and attach it in. So you actually probably joined at a good spot. So yeah, so I'm just building a centerpiece to attach these 4 pieces to, and then we'll stick it in. And I think, yeah, we'll keep the same, we'll kind of keep the same size here. So for starters, maybe we can get away with it being a little bit smaller, 90, just for interest. Maybe a little bit narrower, because our let's see here, our beam radius, yeah, so it doesn't need to be that thick. It can be like 20, and that should be fine. And how we construct this piece in other places, it's going to be like this. So we'll build the center, and then what we will do here is we are going to manually spin these beams around it. So our actual result now is going to be, this is going to be the root. I'm just like seeing how we did with the with this here. Yeah, I gave that an extra root. I don't think we're gonna do that here. We can just have the root be the center. All right, center. And okay, so here will be the center, and then we're gonna add these around it. So that's 1 beam, so we want 4. Range 4. Anchor is going to be, we're gonna add a prefix to this, and the root here, actually we can make this be, so the root of this, just find single root of this is going, we're going to update the transformation to be a where we have a rotation that is mu of tau divided by 4 times index, and then we're gonna add that on here. Piece.cat. And let's see how this looks now. If we did this concatenation right. Oh, that's too small. Now what happened there? What happened there? Oh, oh. We need to actually make the correct rib here. So that's going to be a circle of radius thrust center rad, and these need to be thrusts. Chamfer, and the angle offset 0. We're gonna do 8 subs. Yeah, okay, cool. Now I just need to update the parent as well. So cur equals this. Cur and cur dot parent equals root. Whoops. Boom. Okay, and oh yeah, we've got to add another couple things here. So one thing I can see right off the bat is we're gonna need to make this quite a bit longer, because this is going to be the total length out from the very center. Or should I make this? No, I don't need to do that. I can make that an offset. So we just need to do a better job with our transformation here. So our rotation is going to be this. So our rotation is rot, and our translation equals so beam offset is going to be in X, right? Because that's how we're going to be spinning things around. And we're also going to need to do a flip on this. So like around Z is going to take mu, should see -90, like that. So our offset is going to be the beam length divided by 2 plus the thrust center radius, and this is going to be rotated by rot as well, and this is gonna have to come first. Did that backward. Offset. See, I did it. Okay, almost. We didn't get our rotation in here. Let's try this. So mu view I must be spinning. Oh yeah, this is just a typo. Okay, yeah, there we go. And we just need a little bit of overlap there. So Yeah. And you know what? This is actually not very far off from the scale that I was imagining. If this centerpiece is indeed the right size. So let's attach these things and see how it looks. So now we can just return this part set from here, and we can go back to our building the whole station in our bench. So we can get rid of this and actually, yeah, okay. Get rid of this. Now in here, we have to add in our thrust array 1 and 2. Thrust array equals thrust array LOD. And okay, yeah, why am I not passing LOD into here? That's a good question. I think I can do that. And then we're just doing the same thing here where we're adding a prefix. Okay, and we don't need to do as complicated of a transformation here, but we do need to do the same kind of operations to attach these things back together. So root equals, just define single root, thrust array A dot parent equals root dot transformation equals, just a translation is fine, up to the tower length divided by 2 should be just fine for now. Got to do this again for B. So actually, why don't just redo this in a loop for my using parts anywhere else? I don't think so. Or I could just say thrust array in thrust array A, thrust array height y was like this. So I'm just setting this up to put them on the top and bottom, and this actually makes it nice if we wanted to do a third one in the middle at any point. So here we go. Whoops. So thrust array root vy of y, like that. So let's take a look at this now. Yeah, look at, there they are. And that is pretty much what I was expecting. But what we'll do is we'll actually bring them down a little bit, and we can actually make that plate a little bit smaller too that they're on. And I think I want You know what, just looking at this, I thought it would be cool to have 4, but I think 3 should work, because we would still get the like degrees of freedom, and then I can align it so that it's not lining up with the radiators. So actually, let's do that. And first, it's just fun though, because this is the great thing. Like, I can basically decide however many of these things I want, and it just happens instantly. I'm gonna get rid of this guy. So we're done with that. Okay, so yeah, and then we want to actually subtract half of the thrust center length. We want to add half of that here. And subtract it here, plus some overlap. Some offset, which we'll just define right here for now to be like 1, 2.5. Just make sure that this, yeah, because then that way, oh, interesting, we've got a little overlap there. We'll bring that into Blender and look at what's going on. It could be that I'm not actually constructing this right, the right length. Center len. Plus. Oh, I want to add the offset here. Oh, yeah, that's the problem. Okay, so here I don't want to have an offset. Here I do want to have a slight offset, and it shouldn't be even this much. It should be like this much. Okay, so now let's make three of them instead of 4. So that's just as simple as doing this, and then we'll tweak an offset if it doesn't line up right. Oh, and we gotta do tau divided by 3 here, and we want to add tau divided by 6 times index. I like to use tau instead of pi because it's easier to reason about like whole revolutions for angle offsets. Pi, like radians, of course, are superior to, yeah, we actually want 12. Radians, of course, are superior to degrees, but sometimes it's easier to think about things in terms of, okay, now I'm all horsed up. Okay, let's just start with no offset and go look. We'll look at this more carefully. I'm missing something obvious. Okay, so with no offset, we have this aimed right, this first one aimed right down the x-axis, and we want to pivot this up so that it is that not tau divided by 12? 1, 2, 3. Plus mu dot tau divided by 12. Maybe I just wasn't looking at it quite right. Oh, that's right. It needs to be minus. That makes sense. Yeah, there we go. So now these things aren't lined up with the radiators. They're offset. That looks really good. And then can we make this smaller? Or yeah, here's an idea. Instead of making it 6-sided, we could make it 3-sided. What we want. So the interesting thing about this design is it has this kind of odd bundle of towers shape. Maybe I do want to like actually have this accumulate into the total length of the station beyond these final segments. Yeah, that's probably would be better, because then that would give me freedom to make it smaller. So let's do that, and then we don't have to worry about these offsets either. So let's take a look at doing that, and then we'll probably wrap up, because we've kind of gotten this to be where we want it. So here, this will be minus this. This will be plus this. Tower len by 2 plus thrust center len plus this on this side, and tower len divided by 2 plus thrust center len on this side. And let's take a look. I think that's it, because then we should see the complete segment with its bevel in here. Yep, that looks right there. And over here, oh, our lower offset needs to be increased. So tower len minus thrust center len. Yeah, look at that. And you can see the bevels there. Beautiful. Now, yeah, now we can basically make this any size we want. So, and I want to make it 3-sided rather than 6-sided, just for some additional interest. So let's do that. And we'll give it a bevel. So center bev, we'll give it a 20-meter bevel. So originally we just had this. Now we're going to have a 3-sided thing of that same radius, but give it a bevel. Mu dot bevel polygon chord of rib thrust center bev. And then we're going to want to rotate this to match that negative tau divided by 12 rotation that we gave the beams. So is that what we want? Yeah. And we could calculate out exactly what the like radius of the middle of that beveled face that we created is, but I'm not going to bother. I'll just adjust it with the overlap to make it line up. So we'll rotate the mesh through minus tau divided by 12, and that should do that, and we'll be prepared to take this overlap, and we'll call this offset rather than overlap because it's not actually oh, that actually looks okay. Yeah, it just needs a very little tweak. Like maybe let's see. And I'm gonna make this positive so this can be negative. So it's clear what's going on here. And that is almost right. I think I want a bigger radius on the center now, and I also want a bigger bevel. So this is going to take a couple iterations to get it right. Huh, no, that doesn't look so good. What am I picturing here? Let's see how it looks on this end. It's almost like it needs to be a lot smaller to not look weird in relation to the tower structure. But it looks a little bit weird to have this smaller this piece that's smaller than this kind of going into this bigger bottom section. Like it doesn't look so weird up here. Maybe it does look weird up there too. Let's just try something here. Let's make this a lot bigger and this a lot bigger. See how that looks. I just don't want too many of the same kinds of like repeated shapes stacking up. Like honestly, even these repeated bevels here look a little bit gnarly. And that's too big too. Okay. I take it back. We're going to go back to the we're going to go back to the original design for the center. And I will think about it and see if I can come up with something better. But I think this, yeah, this was good. I think this is what like 90. That looks better. And what I'm going to do here too is I'm going to put a tighter chamfer on this. So we're going to do 2.5 just for some visual contrast between. Yeah, that's starting to look really good. Okay, now one issue here. I'm just seeing this. Oh, I need to adjust the number of sides too. We're still doing 8. This needs to be 6. Yeah, and I think here it's kind of contrast how, like in these other spots, we have the spokes going into flat sides. Here we have the spokes coming out of corners. So that's a little bit of contrast. And you know what? You know what I could actually do here? Could I add a little? I could add a bevel on those corners too. That might look good. Yeah, now that looks nice. That looks good. Just be a little bit bigger. And then see, this kind of goes with sort of another, another sort of level, another kind of higher, like a mid detail piece, because like there ends up being like more sides and more bevels here. It's smaller, like compared to this. I could actually even make this bevel here smaller, just to set it off more. Yeah, and then that kind of is it ends up being sort of a nice nice thing there. Let me just check where these comma rays are ending up. And actually, you know what? Just quick, I'm going to do the same thing with these comma rays that I did with the thrust array and with this little loop here. So, for com array y wrote in com array a B what's this offset 0? Oh, that's that. What? What the heck is this? Oh, that's the X offset of the tower. So this will be the translation. The whole translation, and so here our translation is this whole thing, and our rotation is I3. I can't believe I don't have identity anywhere, but that's okay. So we'll just indent this for clarity. This is kind of complicated. And then here we have comma ray B. With this translation. And y. And this rotation. Okay, so we've got, I just add another layer of nesting in here, because why not? Almost done typing, and we're going to get it into the game really quick here. So this is all in y vector, and that's x offset. This is all in a y vector plus, and this one doesn't have a x offset. That's kind of the difference here. But we have to add, yeah, the lower lengths here. So that's kind of the difference between the upper and lower comma rays. And okay, comma ray B. Everything still look good? Yeah, I think so. I think it's looking pretty good. This I feel like is maybe too deep in. But I think we've got to look at it in Blender to see if there's an alignment issue. So, and I think we're ready to do that. So let's turn this guy back on, and we can take a look at this in Blender. Nice thing about Blender is you can get some really nice like orthogonal views that you can use to check whether parts are lined up like you expect. And you can see we have like that much offset here on that side. I have that much offset there on that side. I think that looks the same. Here, and you can also measure. You can also measure. So yeah, I think maybe I'm just incorrectly adding offset here because I'd like these things to sort of have the same story height. Let's take a look and see if we can figure that out, and then we'll call it a night. So let's just measure here. Yeah, that's definitely too small. If we go to here, that looks like it's around an offset of about 1 meter, and I think this is scaled by 5. So let's see if this is the same. I suspect that it is. Yeah. But yeah, now like if we measure this distance, that's about 2.8. Is this also 2.8 or is it bigger? No, it's actually smaller. Good. So whatever the difference is between these two, that's how much we actually need to offset, which isn't quite what we're doing now. Otherwise though, let's take a look at the end. See, yeah, and that looks really nice. Maybe this top one could be turned no, I think it's fine. It's a long enough way from the rings that doesn't matter. Cool. Well, this is looking good. Yeah, let's try to fix that offset. See what's going on there. C-array support upper height divided by 2. Yeah, and see that is not right for the COM array. We should be adding height extra is 5. All right, and that's then yeah, that's right. That's because that 1 is 5. So let's actually make this guy a C-array height extra. Extra and upper height divided by 2. We can replace this with height extra. Right? I think so. And we won't check that now, but we will do the same thing here. So schema.carray height extra. Carray height extra. And actually, just for the sake of showing what the difference between these two things is a little bit more clearly, we'll do this. And let's take a look at how this looks. Now, I just love this. 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000. So like 5 seconds we're here in Blender with it. Just love it. And, oh, fail. Oh, we need to add, let's see here. It's the same offset issue here on the bottom. Okay, yeah, because the origin is like the middle. Support upper height divided by 2. Support. Okay, so that's the total, yeah. That's interesting. Something weird is going on here with the way these supports are aligned, actually. It seems like the way it was written before should have actually worked. So I will investigate that, not on stream. But I think we made some pretty good progress here. We have these thruster arrays, and they're pretty much what I was picturing. We were able to make a nice adjustment away from having 4 of them to 3 of them, and it looks pretty good. I'll show it in the game next time, and we'll get materials and stuff on there too. But yeah, some good progress, and I think it works well for that kind of like mid detail quality that I was looking for as well. So I think my intuition there was right. Well, thanks everyone for coming. Thanks Dougwise especially for hanging out. If you have not yet subscribed to my channel, subscribe so you can stay up to date with work on the project. I'm going to be trying to post more just short videos of things separate from live streams. So stay tuned for those. Like I said, I went down the rabbit hole of color space, video color space stuff. So I'd have some nicer videos to show. So take care, have a good night. I'll see you again soon.